Okay, class, so now we are in section 1.7, linear inequalities and absolute value inequalities. This is the last section that we will go over before we jump into task number 2. There will be 2 parts to this lecture. This is the first video, and the second video will follow. So, when we talk about the linear inequalities and absolute value inequalities, keep in mind that these are the same type of problems that we've been doing before. The only difference is now we will have a less than or equal to, less than, greater than or equal to, greater than sign. When you see those, there's some little mechanics that you have to keep in mind when using these inequality symbols. However, we get into those right when we get into the problem, simply because I think that is when you will start to understand them a lot better. Before we do that, it's also graphing that goes along with this as well. So there's certain other mechanics to recall when we talk about graphing. Whenever we're doing graphing and you see this symbol here, this means intersection. Whenever we're doing graphing and you see this symbol here, this means union. So let me write that down right beside it. This is intersection. This right here is union. For instance, if we have a graph where a problem that says find the set 3, -3, comma infinity, the intersection of -infinity 1, -infinity, and 1. First thing we would do is draw the graph for both of those on a number line. So, draw our number line out, put 0 here, 1, 2, I know it should be -3, 1, 2, 3, -3. Okay, then I put my bracket on a -3, infinity goes on forever this way, so I'm just going to draw this line just like that. Just put an arrow. The arrow means infinity, it goes on forever. Then let's draw this graph right here. And it's good, let's draw it right up under this one right here. 0, 1, 2, 1, 2, 3. This one says it stops at 1. So I'm going to put a parenthesis here. And I'm going to draw out like this. Alright. Because that one goes on forever. So something to keep in mind when we talk about these symbols right here. One is, I'll write it like this, brackets and parentheses. When we say brackets, brackets is really saying that the value or endpoint is included as part of the interval. When we see parentheses, we're saying that the endpoint is not part of the solution. So that's the difference. With brackets, the endpoint is part of the solution, such as -3 is part of the solution. With parentheses, it's saying that this 1 is not a part of the solution right here. Let me write this 1 right here, because actually that's, I'll stop at 2. This should be 1, 2, 1, 2, and the parentheses should be on the 1 because it's 1 there. I made a mistake and had to place it on the 2 at first. Okay, so now that we have this, it's asking for the intersection. So when it asks for the intersection, we take the part of the number line that each graph has in common. Okay, the part of the number line that each graph have in common. And that would be that there, and right there. So both graphs have this part right here in common. So our answer would be -3, comma 1. Comma 1. 1 is a parenthesis. 3 is a bracket. So we just graphed it as well as found the solution set for it. So that's it for this problem right here. We've done it. It's asked for the intersection. We found the intersection. And then the intersection is confined between -3 and 1. And we wrote it out just like that. Okay, let's do another one. Except this time, instead of getting the intersection, we're going to get the union. Okay, let me just find a set of 1, 3, 1, 3, brackets, the union, and that would be of 2 and 6. 2 and 6. All right. So, same way as we approached the previous problem, which we drew the graph, we're going to do the same thing here as well. So, I'm going to draw this graph here. I'm going to say 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Draw another graph. 0. And it's very important to line both of the graphs up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so let's graph the first one, 1 and 3. We have 1 here, 3 here. And we have this space right between there. All right. The second one, 2 and 6. 2 here, 6 there. You draw the space right in between both of those. I'm trying to make this real dark so it can show up. You will see where the graph stops and is. Okay. So now this one is asking for the union. So when we're asking for the unions, we're taking the portion of the line representing the total collection of the numbers in the two graphs. So we want the portion of the line representing the total collection. The total collection means really everything that's contained between these two. So that would start here and end here. That's the total collection. So with that in mind, we know our answer would be, starts here, this is 1. It will be 1, comma, what does it end? 6. 6. The 6 is bracket, is a parenthesis. The 1 is a bracket. And that will be our answer to that one right there as well. So that's how we graph and interpret these things here, intersection and union, and understand how they relate to the graph, as well as understand their meaning. Once again, the intersection is saying that we're taking a part of the number line that each graph have in common, whereas the intersection is saying that, whereas the union is saying that we're taking a part of the number line representing the total collection of the numbers of the two graphs. So once again, to repeat it, to clear up any confusion, the intersection is saying that we take the part of the number line that each graph has in common, whereas the union is saying that we take the portion of the line representing the total collection of the numbers of the two graphs. It's important to remember the difference between the intersection and the union when you're actually finding the set that's been represented by each of these here. Okay, so I'm going to erase this, and now we're going to solve some problems. So if we had a problem similar to, let's say, let me try and get one. Okay, let's say 3x. We've done something like this before. 3x plus 2 over 4 minus 3 less than or equal to 9x plus 1 over 8. If we take that, once again, we have a fraction. First thing we do is find what? The LCD. We know the LCD of 8 and 4 is 8. So we multiply everything by the number 8. We multiply this by 8. This is going to cancel out, and it's going to be 2. So this is 2 over 3x plus 2. 8 times 3 is 24. Less than or equal to, this 8 is going to cancel out, 9x plus 1. So now, let's distribute this 2 throughout here. This is 6x plus 4 minus 24 less than or equal to 9x plus 1. What do we have in common on this side here? The 4 and the 24. So 4 minus 24, that's minus 20. So 6x minus 20, 6x minus 20 less than equal to 9x plus 1. We'll have that there. Now let's add 20 to both sides. Add 20 here, add 20 there. This is going to cancel out. 6x less than equal to 9x plus 21. Now, let's subtract 9 from both sides. Minus 9x here, minus 9x there. And 6 minus 9x, that's minus 3. X less than equal to 21. Okay, now we divide both sides by 3, negative 3. Negative 3 here and a negative 3 here. When you're dividing by a negative number, it's very important to remember this. When dividing by a negative number, this changes the sign, the inequality sign here. So this is x. It's not less than or equal to. Now it's greater than or equal to minus 7. X is greater than or equal to minus 7. So this will be part of the answer. The other part, now we're going to graph that. So we come over here and we find what negative 7 is at, right? 0, 1, 2, 3, 4, 5, 6, 7. That's our negative 7 there. And now we know it's a bracket. Solution set is x is greater than or equal to negative 7. So everything that's greater than or equal to negative 7 is this way. So it's heading out this way. Not back this way, because it didn't say less than or equal to negative 7. It said greater than or equal to. So 6 is greater than or equal to negative 7 and negative 6. A negative 1 is greater than or equal to negative 7. A 1 is greater than or equal to negative 7. And it continues to go way out there. And then if we had to write this in notation, it would be negative 7, comma, infinity. Why infinity? Because it goes on forever. Everything that way is greater than or equal to the negative 7. All right. That's what that is saying. The solution set consists of all real numbers that are greater than or equal to negative 7. So that's it for that problem right there. Let's do one more. All right, 5 less than or equal to 3x minus 4 less than 18. So for a problem like this, you see how it's set up? We have a less than or equal to and a less than. Still, we want to get the x all by itself. The first thing we do here, we add this 4 to this side. We'll add it to this side. Look what this is going to do. It's going to knock that 4 out. Now we just have 3x there, less than or equal to. So 5 plus 4 is 9. This right here is 22. Then divide everything by 3, because we're still trying to get this x by itself. 3, 3, and 3. So now we'll have 3 is less than or equal to x, which is less than 22 over 3. So if we had to put this in set notation, it would be 3, comma, 22 over 3. Bracket there, that's less than or equal to. You remember, if it's less than or equal to or greater than or equal to, it's the bracket. If it's just less than or greater than, we just use the parentheses there. Then we have to go and let's graph this thing here. So if we graph it, I'll graph it right here. I'm going to say 0, everything is positive, so I can go back here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. So my 3, I could put this right here like that. And then 3 and 22, that's 7, 21, so 7, somewhere between 7 and 8. So I'm just going to put my parenthesis right there. And then draw my connection between these two guys right here as my solution. All right, so that's how I would graph that, and then write it in set notation as well, because it's saying that the set consists of all real numbers that are greater than and equal to 3, greater than or equal to 3, but they're less than 22 over 3. And that's exactly what this graph says. Okay, so that concludes this first section for 1.7 linear inequalities and absolute value. And stay tuned for the next section. Thank you.